Hi there. Light is very interesting, as you may already know if you've watched one of our previous videos about light. In this video, we'll be talking about a very interesting feature about light. This feature is about what happens to light when it passes through very small holes. This is Z Online School, and in this video, you and I are going to be looking at the pinhole camera. We're going to do this in a systematic way, and by the end of this video, you should be able to know what a pinhole camera is, how an image is formed by the pinhole camera, the effect of the pinhole size on the image, and at the end of this video, we've got some bonus tips for you. So make sure you watch this video till the end to get the maximum value out of it. The first thing we're looking at is what a pinhole camera is. By definition, what you note is that a pinhole camera is just a device that will be used to form an image without using a lens. Most cameras now use lenses, but some time back, what was found was that images were formed if light passes through a very small hole. In structure, a pinhole camera will be as follows. We'll have a box and a lid. For our box, we need to have some major parts. The first is this hole here, which we are calling a pinhole. It's a very small hole. In this diagram, it might look a bit big, but when you're making an actual pinhole, try to make that hole as small as a pin. The other part is the screen where the image will be formed, and we have a lid. This lid ensures that inside this box, there's no light getting in apart from the small hole here where we've allowed light to get in. This structure can even be made by you at home when you get a box and make that pinhole. Therefore, you can make a pinhole camera just at your home. Now, how are images formed by this pinhole camera when there's no lens? This is because of the rectilinear propagation of light, which is the property of light to travel in straight lines. This property of light is also talked about in our previous video, so you can check the description and click on the link that takes you to that video. Let's say we had an object which is a tree. This object will be reflecting a lot of light. Why are we saying it will be reflecting a lot of light? We know trees don't produce any light. Therefore, for us to be able to see them, they need to reflect light. Usually this is light from the sun if it's during the day. If it's during the night, obviously you have a torch or any other device that you can use to shine and see. If we'll be using a pinhole camera to form an image, obviously we have a pinhole camera. Knowing that this tree will be reflecting some light, we will know that some light will be reflected in such a way that it gets into this box through the pinhole. From the top, we expect some rays to get in, and from the bottom, we also expect some rays to get into this box too. These are mainly the two rays that are very important when the image is being formed by a pinhole camera. However, some diagrams may even include a ray right in the middle here. This is how basically an image is formed by a pinhole camera. As you can see, these rays crisscross, and therefore our image here will be inverted. The ray from the top finds itself at the bottom of the screen, while the ray from the bottom finds itself at the top of the screen. Therefore, this image here will be inverted. Apart from just knowing the image formation in a pinhole camera, it's also important to know the different kind of distances that are important so that we can perform a various kind of calculations that are involved with the pinhole camera. The first distance is the object distance, which is just the distance of the object from the pinhole. It's abbreviated as U, and then we have the image distance, which is the distance simply between the image and the pinhole. Now, you should note that this distance is also the length of the camera box, or simply the length of the pinhole camera. If that term is used, don't get confused and think you haven't been given the image distance. Apart from these two distances that are very important, the sizes of the object and the image are also very important things that you need to note. The object size is abbreviated by O, while the image size is abbreviated by the letter I. This is one of the major things you need to know about the image formation in a pinhole camera. But we cannot go forward without talking about the properties of this image. The first property you can see is that the image is smaller than the object. Another thing you can see is that the image is real. And in physics, when we say an image is real, we are saying an image is upside down. If it's upright, meaning the same way as the object, we call that image virtual or unreal. With that said and done, now let's talk about the effect of different pinhole sizes. We know the pinhole is that hole that is responsible for making the image in a pinhole camera. Now, what happens if that size of the pinhole is increased or reduced? Well, one thing you should understand is that the smaller the pinhole, the sharper the image. This is because when the pinhole is small, very little amount of light is let into this pinhole camera. If there are too many rays of light entering the pinhole, the rays might form a lot of crisscrosses inside that pinhole camera, and therefore the points at which this image will get focused will be many. To illustrate this, let's say we've got an image here where we've got a flower pot with some leaf in it or some flower. If our pinhole is very big, as you can see here in this diagram, what we expect on our screen is a very blurred image. This image might not even look like our object. Now, if we were to make this pinhole just smaller, we would expect a change as illustrated. Our image might look much more similar to our object. With that said and done, you have reached the bonus tip section. In today's video, one tip we want to share with you is the formula for the pinhole calculations. When you talk about pinhole calculations, we're just referring to calculations that involve the pinhole camera. The formula that we use is I over O is equal to V over U, where the I is the image size, the O is the object size, the V is the image distance from the pinhole, while the U is the object distance from the pinhole. Just knowing this formula is actually enough if you do some math. And since we've got 4 things that are involved in this formula, whenever we are supposed to use this formula, we'll be given 3 other things that will enable us to find the unknown. Let's say we've got an example to just show someone how to use this formula. In this example, we've been told an object is 1 meter tall and it forms an image which is 5 centimeters long on a screen of a pinhole camera box. Now we're asked to find the distance of the object from the pinhole if the length of the camera box is 40 centimeters. Immediately you see this sentence here telling you that we're finding the distance of the object from the pinhole. You must know that we're making you the subject of the formula. But before we get into all those calculations, it's very essential that we get our data. If you don't know which one to make the subject of the formula, this is one of the ways that you can be able to realize which one is missing. The first thing we've been given is the object size, which is O. But if we check here, we've got this I here. So let's check if we've got the image size. Yes, we have it. We've been told 5 centimeters long on a screen, meaning that's the image size. So we've got the 5 centimeters, the 1 meter, and the 40 centimeter. This 40 centimeters is the length of the camera box. Remember I said sometimes the image distance might be just mentioned as the length of the camera box. This is because we know the image will always be on the screen. Therefore, the distance from the screen to the pinhole is the same as the image distance. Now you can see we've got I, O, and V, meaning the only missing thing is U. We're going to make you the subject. Some might be asking how we're going to do that. Well, let's have just a quick one through that. We're going to cross multiply since we have fractions on both sides, and therefore we'll be left with IU is equal to VO. And then because we have an I that we don't need, that is combined with the U, we're going to divide both sides by I. Therefore, this side is going to lose its I because the I and the I in the denominator will be cancelled. Therefore, U will be equal to V multiplied by O over I. If we use this formula and substitute our values that we found in this passage, we can have the value of the distance of the object from the pinhole. As we can see, V is 40 and O is 100, then I is 5. What I'll do here is just simplify these two parts here. I won't simplify this because it will be very helpful for me to answer this question fast. I know any number that has got 1 and zeros, if we multiply by that number, we're just going to add the zeros of that number to the answer we get. So I know 5 can get into 5 and 5 can get into 40. So 5 into 5 will give us a 1. 5 into that 40 will give us an 8. Therefore, our answer is just 8 times 100. And if you heard me right, we're just adding these two zeros to this 8. Thanks for watching this video till the end. Now it's your turn to go and make that pinhole camera.